Episode 76, Everybody's Going to Mars. And welcome back for another edition of the Syzygy podcast. Joining me from the other side of the planet, deep within the observatory that she's currently visiting, Dr. Emily Brunsdon. Emily, how you doing?
Hello, hello. I'm doing well, although maybe I'm having, the typical problem of an observational astronomer, and that currently I'm only observing clouds.
That is a bit of a problem with the field that you're in, Emily. You should have chosen something which didn't require clear skies, I think. So just fill us in. Where are you?
So I'm at the University of Canterbury's Mount John Observatory,
right,
which is in the middle of the South Island of New Zealand, on a small little hill above the township of Tekapo.
Right. Okay. So when they say Mount John, it's a little bit like, the mount here in York, where there's no mountains, there's barely even hills. How, you're not right high up in the stratosphere or anything?
Not quite. Well, no, to be fair, I mean, it is a mount, and if it was in Yorkshire, it would definitely be called a mountain.
Right, okay. So just getting the lay of the land, you are actually up at some kind of altitude, yes.
Yeah, about 1,000 metres at the moment.
But by local standards, it's not particularly high.
Well, no, we're kind of surrounded by mountains that are about 3,000 metres high. So,
well, I'm sorry to hear that the clouds are getting in your way, but that does mean that, you're not really, really busy with the observing, which means that we can have a chat about some stuff that we don't need the clouds to part for, because, it's been a fairly big week in the world of space and space exploration.
Absolutely. It's like one of these things. It's like buses, you're waiting for ages for things to happen, and then you get sort of 4 of them at once, and it's like, whoa, that's exciting.
Yeah, very exciting. And they're all of those buses are on the Mars route. So fill us in, Emily. There's been a lot of excitement going on around Mars. So what's been happening? Bring us up to speed.
Well, so just in the past fortnight, we've had 3 missions arrive at Mars. All of them have arrived successfully. All of them have gotten to where they need to be successfully. And everyone is just having a good old party now to celebrate the fact that we're getting quite good at this visiting other planets business.
Yeah. I mean, let's not trivialize this in any way, shape or form. Actually getting off the ground is hard. Getting to another planet is hard. And then stopping at the other end to do the thing that you want to do is hard. There's a reasonably long list of missions that have gotten to Mars and just failed, crashed, or been lost, or whatever it might be. So 3 in quick succession, which have all seemed to be doing the thing that they were designed to do, is fantastic. So, and I think actually the last time we talked about this on the podcast, I got it very, very wrong. I thought that the NASA mission had actually already arrived and was sort of in orbit awaiting to do its thing. But no, that was absolutely not true. It was actually, as we last spoke, it was still very much winging its way at speed towards the red planet. So apologies for that, but we are going to be as accurate as we can be today. So Emily, what are the 3 missions? What's been going on?
Yeah, so we've got 3 that have arrived. So we've got Hope, which is a orbiter come from the UAE.
Mm-hmm.
And we've got Tianwen 1, which is a whole bunch of stuff, as we'll find out, which has come from, sent up by the Chinese space agencies. And we've got NASA's Mars 2020 mission, which has arrived and even launched its rover onto the surface called Perseverance. Yeah,
very exciting stuff. Well, look, can we go through those in order? Because I think that was the order in which they arrived. So we'll leave the Perseverance lander and its little buddy, which is the thing that I'm really excited about, for a little bit later on. Let's start with Hope. Let's start with the UAE spacecraft Hope. Tell us a bit more about Hope.
Yeah, so Hope was arrived on the 9th of Feb around Mars. Now, it might be worth just sort of clarifying up front. It's not sort of that weird that all these things sort of arrive within a few weeks of each other, because to get to Mars, let's remember that Mars is only sort of close to the Earth at some points in its orbit, right?
Yeah.
And so there are what we call orbital windows or launch windows when you launch it off the Earth and you sort of send it out and it intersects with Mars. And that's easier to do when those 2 planets are kind of like Earth is catching up on Mars in its orbit, if you like.
So it's not such a big coincidence. It's not a big surprise that they're all arriving in a short window of each other, because it's a short window.
exactly.
right? That's the whole point.
And that window is only about sort of 780 days long, which is actually what we call the synodic period. So that's when the amount of time it takes for the Earth and Mars to be aligned in the same position in their orbits again.
Gotcha. Okay, so they're all arriving roughly around the same time by design, but Hope was the one that got there first.
Yep. Yep. So Hope is as we say, an orbiter. It's actually designed to orbit relatively far away from Mars compared to what the other orbiters we're going to talk about. And that's because what Hope is going to be doing is actually looking at global weather patterns on Mars. So the UAE, this is obviously well, maybe not obviously, but it's definitely the first time that they've sent a probe to another planet. So, kudos, good job.
Yep,
I mean,
good work.
Well done on getting it right the first time. That's brilliant. That's an exceptional feat.
Yeah, and I was just actually having a look at the mission webpage, and it says that the idea only came about in 2013 that they were going to do this. So that's pretty good.
That's pretty amazing.
To go from that to, hey, we're in orbit around Mars just 8 years later that's pretty amazing.
Yeah, no.
So nice work. Well done, everyone.
Really incredible feat. And yeah, so part of that, I guess, when I was doing some bit more research on it is that, I mean, although these missions come from individual countries and individual space agencies and so on, there is a lot of collaboration that goes on internationally, right?
Sure.
So there's different universities that are involved, different research institutes that are involved, different countries that are involved in parts of these projects. And what you'll sort of see as we talk about all three of these ones is that they're all doing very different things with Mars. And that's exactly what we want, because we don't want to be duplicating effort. It costs hundreds of billions of dollars to send a spacecraft out there. You want to get the maximum science that you can do, and diversity is the way to do that.
Yeah, it doesn't make a lot of sense for everyone to say, no, we're going to put a lander with a helicopter down on the ground. No, we're going to do that. Rather, you spread out the effort, you spread out the different scientific missions that you want to achieve, and say, okay, well, why don't you concentrate on that one? Why don't we do this one and we can collaborate on that one? Yeah, makes a lot of sense.
So when the UAE came along in 2013 and said, let's do this, they spoke to lots of different international groups and said, hey, what would be really useful that we can do with this idea? And yeah, weather was the one that got decided upon to become kind of like just a weather sat for Mars.
Nice.
So Hope is going to be looking at both daily and sort of seasonal cycles and the weather on Mars, and is also going to be sort of probing a little bit more into dust storms and what kind of patterns there are with dust storms going on Mars. Really important to know when you've got things with solar panels kicking around on the ground.
Yes. I mean, I've seen the movie The Martian, and it's not a particularly nice place if that's in any way accurate. You can get some pretty big storms there down on the surface. So that's good stuff.
Yeah, so weather on Mars, really interesting. It's interesting to think about weather being actually more predictable on Mars than it is on Earth, because Mars has a very tenuous atmosphere. It doesn't have a lot to it, unlike the Earth's atmosphere. And that's due to a couple of things. I mean, it's due to the fact that Mars is smaller, it doesn't have as much gravity to hold on to gases for an atmosphere. It also its core is kind of solidified, so it doesn't have a nice magnetic field to help protect it from kind of the horrors of the sun's radiation from space. So all these things are really important. But yeah, looking at dust storms, looking at maybe there's something like a 3-year cycle with dust storms, or you tend to get sort of one every 3 years or so. So are they linked? What sort of conditions lead to dust storms? These are all really interesting questions.
I hadn't really thought about it much before, but I mean, Mars doesn't have bloody great oceans all over it, and the a lot of the weather patterns, a lot of the climate patterns on Earth are enormously complicated by the fact that we have these huge land masses, and then we have these enormous bodies of water, and they behave incredibly differently and have crazy effects on the atmosphere above them, which then leads to very, very complicated weather. Mars doesn't have that. It's got its own set of weird weather parameters. So I'm guessing we probably haven't learned a hell of a lot about that so far.
Yeah, well, we've got lots of questions. I mean, if you cast your mind back even a few years ago, one of our very early Syzygy episodes, we talked about carbon dioxide and seasonal cycles of that on Mars. And so that's one of these kind of cyclic patterns that we're observing that we'd like to know a lot more about. And then sort of in a more general sense, trying to understand, like you say, Mars doesn't have oceans today, but it possibly did in the past. There's lots of evidence for liquid water on the surface of Mars some time ago. So how do you get from that to how Mars is dry, what we see today? So that's a really interesting question to look at as well.
Yeah, good stuff. Okay, well, thank you to the UAE and their HOPE satellite. Looking forward to some really interesting updates from that. So after HOPE, then came the Chinese mission, which is Tianwen-1.
Yes, yeah. And Tianwen-1 is amazing because it's the mission that has it all. It's great.
I guess if you're going to go, you may as well make it worth your while, right?
Yeah. So Tianwen-1 is an orbiter, it's a camera, it's a lander, and it's a rover.
Right. Now, they haven't done the landing part yet, have they?
No.
So that's still to come. So they are in orbit around the planet, but they haven't actually done the landing down on the surface bit yet. But that's all to come. They've got all this stuff ready to go.
Yeah. So the orbiter arrived on the 10th of Feb. But even before that, what was one of the cool things that this mission did was they had a camera on board the spacecraft that was actually designed to deploy whilst it was en route to Mars and just sort of turn around and take a few selfies.
It is amazing. I mean, you sent me this link to this story, which is from October last year. So that's still a long way out from its destination in Mars. We're in deep space here, interplanetary space. But at that point, well, it's just kick off this camera, and it's not on a cord or anything. They're not going to pull this one back in. This is just off you go and just start taking pictures. And I think it was taking pictures like 1 a second or something. And there's these pictures of the Tianwen-1 spacecraft slowly getting smaller and smaller as the camera drifts away into space. And what an awesome idea. But why are we doing this? Are we doing this just simply because, well, that'd be cool. Let's take some pictures from deep space. I don't know.
Yeah, it's really cool. It's very indulgent, really.
It is a bit,
which I like. It's cool.
Although, as you said earlier, the cost to weight ratio for launching something into space is that's a lot of dollars per gram, and so someone in a meeting somewhere had to make that argument, which was, okay, hear me out on this one. Do you know what would be really, really cool is if we had a camera and we did some selfies in deep space. Yeah, but that's going to cost a lot and it would mean we can't pack this thing. Yeah, but it'd be cool. And someone agreed, yep, we're going to do this. I think that's great. Well done.
Yep.
Well done. Okay, so that was back in October, but they've arrived now. They're now in orbit around Mars.
So the orbiter is now going around and it's doing some nice surveying of they've kind of got a loose idea of where they want to stick the rover, but they want to do some more surveys to make sure that they choose kind of the best asbestos place. So that's going to happen over the next couple of months, and they'll choose a landing site, and then they're going to push down the lander and the rover.
See, I find that really fascinating because that's so different to what happened, as we'll get to in a minute, with the NASA spacecraft and the NASA rover, which is that we've picked it, we know where we're going, and we're going there. And China's gone, no, we're going to have a look around for a while, see what we can find. So, you said a minute ago that it doesn't make a lot of sense to overlap too much on mission parameters because, if we're all going to go, let's spread out the load. But if you're going to have a rover from China and a rover from NASA, I'm guessing that they're rovers of a different nature, that they're going to want to do different things. So what's the Chinese mission looking to do?
Well, yeah. So first of all, they're going to different places on Mars. I mean, none of the rovers, if you look at kind of a map of Mars and where all the stuff that we've dumped onto the surface of Mars is, it's all pretty well spaced out, right? You're not just kind of go over the next rise and suddenly see, oh, look, there's Spirit over there.
Yeah, that's right. We were here first. No, you weren't.
So there's a lot of really interesting geology to explore on Mars. And so the Chinese mission is more focused on looking at a lot of the geology that's going on Mars. So part of their, what actually Tianwen-1 means in Chinese is it's referencing to a very old poem, but it kind of loosely translates to heavenly questions. So kind of this idea of exploration of the heavenly ideas that you might want us to find out about Mars. And that's quite cool because then if you look at then what it's actually looking for in the geology. They're looking for kind of both present and past signals of water. So, is there liquid water there now, maybe just under the surface? But more importantly, perhaps, was there liquid water in the past, and where was that? Looking at interior structure of Mars, doing some rock samples, kind of using the surface features to understand a little bit of Mars's history, but also doing a little bit of the kind of the space environment and atmosphere measurements while it's there as well.
Am I right in saying it's fairly well, I don't know whether the word is established or believed, that Mars once had a fair amount of water on it? Like, there's a lot of evidence for this sort of thing. But how sure are we of that? Like, is that for definite?
Yeah, well, it pretty much is. We see lots of features on Mars that look like they were formed by what we call fluvium processes, so water liquid processes. And so there's a lot of evidence for that. And most of that has come from reconnaissance orbiters. So these kind of orbiters that take really nice high resolution pictures of different sort of features. What we haven't, I don't think, really seen is kind of any direct measurements of water now in anywhere apart from the polar caps. Right, there's a bit of water ice sort of locked up in the polar caps, but we haven't found any direct evidence for liquid water sort of anywhere else, at least existing now on the surface.
Right. And it's like other liquids are available. People feel like it would have definitely been water, or could it have been something else?
Well, I guess that's an open question. I think mostly we understand it to be water because that's kind of one of the most abundant sort of fluids that you can have in the Martian sort of geological backstory of time. But yeah, it might not be kind of ocean salty water like we have on Earth, but it will have its own sort of unique properties, being Martian water, if you like.
So you were saying that Tianwen-1, the mission is going to be looking at geological stuff. Here on Earth, we do a lot of geology by looking at the surface features, but we also do a lot of geology by digging down as far as we can. And let's face it, we can't dig down terribly far, even on Earth. That we barely get through the outer crust layers here on Earth. But we can also do, seismological studies where we can, pound enormous shock waves down into the ground and see how they ricochet around on the different layers down underneath the Earth, down underneath the surface of the planet, which we just can't do on Mars. So I'm guessing that anything that we're going to be doing down on the surface of Mars as far as geology is concerned is really just looking at the surface features and going, what can we reverse engineer from that? What can we figure out? Would that be right?
Yeah, well, to some extent, but also we can do some measurements of like interior processes as well. So, for example, the rover has got ground penetrating radar on board, so it can do radar measurements to look at some interior structure. And it's got the lander, I think, has got a seismogram on it to look for any sort of seismic activity. The rover's going to be measuring the magnetic field strength, the local strength of that. So doing a little bit of this kind of more indirect measurements of what you might find it's not a direct kind of let's drill down and 3 kilometers into the interior of Mars and see what we find. But we can do, and it is going to be looking at samples, and you can do sort of very basic chemical experiments with samples that you sort of, and Curiosity is another rover that's done this as well, where you pick up little bits, you can kind of put it in a test tube, put some chemicals in, shake it around and see what color it changes to. I'm not very good at chemistry, you might be able to tell, but
I'm sure there's coloured liquids involved in there somewhere, I'm sure, and titration or pipettes or something like that. Any Martian chemists out there want to get in touch with us and explain to us exactly how this works, feel free, that's fine. But we've come a long way from what I do remember in some of the early rover missions where, these were very small devices trundling along, doing their best, basically just proving that it could be done at all. And I remember there being reports coming back where, the cameras had picked up these rocks. They kind of look like the same sort of rocks that we have down here on Earth. That must mean the following. And that's pretty basic level, really cool, but pretty basic level Martian geology, which is the shape of that rock looks quite similar to the shape of this rock that I've got sitting here next to me on Earth, so therefore I think this. And this is much more sophisticated than that. There's some chemistry involved, there's a bit of seismology and a bit of underground radar and so on. So, we're moving not quite at the rate that we would here on Earth, but we're picking up speed. It's good.
Absolutely, yeah. And we can do, of course, spectrometry measurements as well. So this is just looking at the light that's reflected off rocks, instead of saying, well, what is the chemical species of these rocks? So they are much more precise measurements than the kind of things of that, that looks like it might be an igneous, or that might be a sedimentary. Again, my geology, maybe not the best.
Indeed. Look. Basically, anyone who knows anything about any field that Emily or I aren't experts in, you want to get in touch, just, teach us a few things, feel free. Okay, you said it had a whole bunch of stuff on it. It's got the lander, it's got the rover, but it's also got something which is going to stay in orbit for a while.
Yeah. So the orbiter's got cameras on board. So the cameras on Tianwen-1 go down to about 100 meters on one camera on the medium resolution, and 2 meter resolution on the high resolution camera, which is pretty impressive. It's doing magnetic field stuff. It's doing spectrometry again, radar measurements, particle measurements. There's I think if you add up all the different instruments that are on board, these kind of three things that are sort of going to be trundling around Mars pretty soon. It's quite astonishing, actually. It's quite a lot. It must be about, I don't know, 10 or 12, or at least different sort of bits and bobs that are probing Mars.
Yeah, I mean, as you say, the window doesn't come around literally every day. So if you're going to send a bunch of things to Mars, then let's pack as much as we possibly can into that window. And as it turns out, Mars is going to be in the news of astronomy and space exploration for a while, because we've only just got there. There's a lot of data left to come, so that's very cool. Do we have any idea when they're planning on doing, when the Chinese mission is planning on doing its landing of the lander and the rover? I mean, they're looking around for a site.
It should be within the next couple of months, so I think they're looking at May, June, so okay. Not too long to wait.
That'll be exciting. But they do have a hell of a show that they need to compete with, because NASA just in the last couple of days has done some pretty extraordinary stuff. And did you tune in to watch live, Emily?
Absolutely, yeah. I couldn't miss that one. It's really, really exciting.
It was very exciting. And even though there wasn't a hell of a lot to watch live, it wasn't like we were getting a live feedback of high resolution images as the latest NASA mission is heading down towards the surface. But I just found it so compelling to watch from Mission Control. A lot of really, really excited and extraordinarily nervous people, calling out, this has happened. Okay, that's happened. Yep. Is that going well? Is that what we expect? Yep, that's good. And then finally it's all over and they've actually landed on the bloody surface. It was just so cool. Very, very exciting. So Emily, take us through what's actually happened, who's done what.
Right, so NASA's Mars 2020 mission, which again launched mid last year, has arrived at Mars, and the launch happened. Then it launched straight back down when it arrived. The rover Perseverance and its little buddy, which is called Ingenuity.
Yes.
So this all happened on the 18th of February.
Yes, very exciting. Just a couple of days ago. It's Wednesday the 24th as we're recording, so it's a few days ago now. But we've had enough time now for everything to be checked out, for all of the systems to be made sure that they're operational, and for some seriously awesome footage to be sent back. So we can sort of go through some of that in a bit. But yes, back on the 18th, it was very exciting. And they used with still what I think is borrowed very, very closely from science fiction, the whole notion of the sky crane sending this thing down to the surface.
Sky cranes are just amazing.
Just amazing. What's a sky crane?
Yeah, well, it's really interesting. So let's backtrack actually a little bit to Tianwen-1, because Tianwen-1's got a lander, and it's landing in what you might imagine to be the more traditional way to land on the surface of a planet.
Okay, when I imagine that, I imagine sort of, your classic sci-fi style rocket coming down towards the surface, and it's got to slow down. So maybe it uses a parachute or something. It's got some rocket boosters that it points in the opposite direction to slow it down, and slowly but surely, with any luck, without too much of a bump, it lands on the surface. That's what landing says to me. It's a bump.
Absolutely. Yep, that's exactly what it is. So parachute, then some jets to slow you down. Remember that Martian atmosphere is, again, very thin. It's actually quite hard to slow yourself down. It's kind of 9/10 of the problems that we have landing on the surface are actually slowing down.
Yeah. I mean, the gravity isn't as strong, but then again, you haven't got as much pushing against you. So 6 of one, half dozen the other.
Yeah. So then you land, and then kind of a little ramp comes off the surface of your landing craft, and there's your little rover. You drive off, and you're away off into the sunset.
So, okay, that's the traditional way of doing it, but that's not what NASA did this time. This time, they did something very clever.
Yes. So, well, the thing is that you might have noticed if you look at the NASA rovers, particularly over the last couple of decades exploring Mars, there's definitely a trend towards getting bigger and bigger rovers.
Yeah, I'm just looking at some images now from NASA of comparing the sizes of them. And the first one that they put down, which was from the Pathfinder mission. What was it called?
Yeah,
It was
Sojourner.
That's the one. Yeah, and it's just this tiny little, almost the size of a kiddie car. You know, the sort of thing that you used to play around with, a pedal car when you were a kid, with solar panels on top. And then we get a bit bigger to the next ones and a bit bigger to the next ones. And now the 2020 mission, Perseverance, bloody huge.
Yeah.
It's the size of a modest car. This is non-trivial now.
Exactly. So it was there was just the last mission, actually. It was Curiosity they started to get really worried, actually, and thought, these are getting a bit big. They're getting a bit heavy. I don't think this kind of traditional way of landing where, so for example, with the Spirit and Opportunity, the previous mission, they had kind of that same parachute jet things. They had these big airbags that kind of cushion the landing. That style of landing wasn't necessarily going to work very well when you up the mass and up the size of your spacecraft.
Well, not just mass and size, up the cost as well. I mean, the stakes are really rising here where, like, we need to get this onto the surface and working. Otherwise, it's a hell of a lot of money and time to replace it. So can we get this right, please?
Exactly. And, you've got lots of sensitive scientific equipment on board. You don't just want to sort of fire this thing and smack shit into the planet and hope it all survives. It's got to be done very reasonably gently. And so the idea sort of came to NASA that maybe we could try this more gentle way of dropping something onto the surface of the planet by the use of a sky crane.
Fabulous idea. So take us through how that one works.
So you still have your initial descent sort of phase with parachutes and so on. That's still all the same. But then what happens is once you get about between sort of 7 and 10 meters off the surface of the planet, then instead of sort of just going down gently by firing some sort of rockets to sort of slow yourself down, you actually use the craft which is holding onto your rover to lower via like a little tether. You just sort of lower it down gently onto the surface of the planet. So it's kind of like a bottom crane, an upside down crane where you're just dropping something quite gently down.
Which just doesn't sound possible. I mean, if you think about spacecraft coming down and it's got a parachute which is slowing it down, and it's got these jets on the bottom which are sort of stabilizing it, and then off the bottom of that it lowers down a bloody great heavy piece of machinery to land on the surface. It just doesn't sound possible.
It's crazy.
And then when you think that all of this is happening where the people who are trying to make sure that it's all going smoothly and are holding their breath and keeping fingers and toes and everything they can crossed are a 25-minute or something round trip communications link return time away. So, everything is happening over a timescale in which if something goes wrong, there is literally nothing you can do about it. Nothing.
Exactly. Yeah, there's no live driving of anything that you can do on Mars because of the time delay with the communication. So, yeah, so you have to program these things to just sort it out themselves, basically. But it was a fantastically successful system that worked with the Curiosity rover, and so we got Curiosity onto the surface this way. And so actually Perseverance is a little bit like a kind of slightly bulked up version of Curiosity. It's pretty much the same technology, but just a little bit bigger.
Yeah, I'm bringing up some pictures now. Curiosity was back in 2012, I think, when we landed that one. And it's, that's a sizable piece of kit. But Perseverance is then, as you say, kicking that up another notch. But they are, you can see the obvious family resemblance here. They look very similar in many ways. Just Perseverance is the big bulked up version. It's been working out. So that all went well. The sky crane went well, and there's as I said, when we were tuning in live the other day, we didn't get all the live feed images back in real time going, yep, there it is, it's happening. But we now have some really quite amazing footage. So if you haven't seen it yet, do tune in, and we'll put the links in the show notes. There is actual video footage from the lander itself. First of all, you get to see the heat shield fall away. So that's, as you're slowing down, coming into the atmosphere, you've got to have a shield to stop yourself burning up, basically. And that drops away. And so, the beginning of this video footage is, I can't see anything. It's dark and blank. And then suddenly it opens up and you can see this heat shield dropping away down towards the surface of Mars. Oh my God, that's the surface of Mars. But then from the other angle, looking upwards, you can see the spacecraft that is dropping it down on the sky crane as Perseverance is making its way down. So you can see the cables and the data cable following it down. And it's like, oh my God, we're watching this actually happen in, pretty high resolution footage from the point of view of Perseverance itself. It's absolutely amazing.
Yeah, it's so cool because you can see side by side the two cameras. So you can see the Perseverance going down from the top of the crane, and you can see Perseverance looking up to see how it's going as well.
And then all the dust gets kicked up as it gets close to the surface, and then suddenly it's down. But the other one that really blew me away was did you see the image from one of the orbiters going around, which took an image sort of from a bit of an acute angle looking down towards the surface of Mars. And if you zoom in, you can see the parachute and the spacecraft underneath it in the midst of dropping the rover down onto the surface on the sky crane. It's like, oh my God, someone took a picture of that. That is amazing.
So cool.
So exciting. Yeah. So it's down now and everything's working happily. Everything's A-okay.
Yeah. I mean, so we had the sort of massive excitement of the landing, and then you got the first pictures that sort of came through actually remarkably quickly. I was astounded. It only took kind of a few minutes after we got confirmation that it had landed successfully, and then suddenly there was this first picture that Perseverance had ever taken on the surface of Mars. And it's actually a pretty good, well, I thought it was pretty good for a first go. I mean, when the dust is still settling and, you can see some sort of rocks.
Kind of looks like you're looking through a porthole, through a murky porthole. But as you say, given that you have literally just landed on the surface and there's a lot of dust that's been kicked up, to immediately then take a picture before you've had a chance to even, wipe your eyes, it's pretty bloody amazing. And the fact that was able to come back so quickly to say, yep, we're here, we made it, was
proof
very
of landing.
exciting.
Yeah.
But we've had more than that.
Well, and then, of course, Perseverance is on Twitter, just like all good Martian rovers are. And so its first little tweet was, it's hello world, if you like, on Mars, was my first look at my forever home. And I sort of thought, there's something really bittersweet about that.
Yeah, there is. I mean, there's a certain sense of fatality about it, that, well, I'm here, it's exciting, I guess I'm never going back to Earth though, so let's hope this works. Really long time. Yeah, so that's very cool. And so if you're not following at NASA Persevere, then you really ought to, because, well, a couple of reasons. Number one is because it's kind of cool that there's a Twitter account being run by, at least in principle, the little rover that's down there on the surface. I'm pretty sure that there's a PR person, human being at NASA headquarters who's actually doing the stuff. But, let's not ruin the magic too much. Second reason is because that's where you get, all of the latest up-to-date stuff that they're putting out about the mission. And so it's a really good resource. But the third reason is because just in the, in the short period of time since they landed on the surface, there's already been a whole bunch of fake stuff going around saying, hey, look at this amazing video with sound that has come back from Perseverance. Like, no, it's not. That's video or an image that was taken like several years ago by Curiosity, and you've just dubbed wind sounds over the top of it. That's not real. Okay, so don't be taken in by the nonsense. And if you don't want to be taken in by the nonsense, go to the horse's mouth, which is at NASA Persevere. And you can be sure that that's the real thing.
And it's just, I mean, it's adorable. I love this anthropomorphication of rovers. I mean, it just makes them so much more, I guess, endearing, and what they're doing so much more exciting in a way as well. Because you're kind of thinking about it from the rover's perspective. What I did like, sort of scanning through just before the landing, actually, was that Hope tweeted Perseverance to say, "Good luck, buddy. great that you made it to Mars. Hope your landing's all good.
Good luck.
See you soon."
We're rooting for you. I mean, that's very sweet. I like that. It must be quite fun, actually, to work on that side of communications for these various organizations, because, I mean, you would be collaborating very, very closely. That's the nature of these things. But then to also sort of, I don't know, work together on how can we really build up the excitement around this, to be able to riff off each other in that way is really kind of nice. So let's hope that continues. So what's been happening in the days since we touched down? They've been testing things out. Have they actually driven anywhere? Has it moved?
No, not yet. So, once, I think everyone's first of all just taking a few deep breaths and saying,
yes,
maybe
having a stiff drink. Yeah.
Yes. Let's just all come back to the reality of we're now on Mars. This is great. Now, there's quite a long sequence of testing that goes on when you land such a complicated piece of machinery, right? So they're very, very, very cautious. You certainly don't want to turn everything on at once and then it just to go poof.
Yeah.
And then suddenly it's all gone.
All right, come on, we're there now. Let's go. It's not like that.
No. It's very, very conservative. So you turn on every little individual sort of system one at a time, and then you see if it's doing what it should be doing, and then you turn it off, and then you turn on the next one, and it's just a really careful check that everything is going well. And that whole checking process takes 4 to 5 days for a system as complicated as a Martian rover.
Yeah, and fair enough too.
But they have turned on a couple more of its cameras. So I found this just absolutely astounding. So Perseverance, do you want to have a stab at how many cameras Perseverance has?
Oh, look, I mean, at a guess, I'd say lots, but...
So Perseverance has 19 different cameras on board.
Okay, if you'd pushed me, I would have zeroed in on a dozen. So 19, that's a lot. That's a lot of cameras.
Yeah. So the initial sort of pictures that we were getting from Perseverance were actually from kind of more the engineering cameras. These are just cameras to check that things are going okay. They're not designed to make beautiful posters that you're going to put up on the walls of your sort of classrooms. They're not Hubble Space Telescope images.
The first image that came back, where it kind of looks like it's looking through a porthole, wasn't that from sort of one of its relatively low resolution? Did we make it? Is there something in our way? Are we tipped over on an angle? Something like that. So it's not designed to be, as you say, the really high resolution. Wow, check out the surface of Mars. So much as, are we all right? Is this thing the right way up?
Yeah. So really low resolution, just so that you can get the picture sent really quickly, just to do a systems check. But since then, other cameras have been coming on. So we've seen, first of all, a few pictures of wheels. That was a good one. So having a look at the wheels. The wheels are really important, actually, because Perseverance needed to have some kind of new, stronger wheels than Curiosity. Curiosity's wheels are not doing so great after its kind of loads of kilometers of sort of traipsing around on Mars. So wheels are quite important, it turns out, on Perseverance. So we've got some pictures of wheels. Perseverance loves rocks, apparently, according to Twitter. It's it wants to look at the rocks next to its wheels.
I mean, that's lucky because there's not a lot else at this point. You've got rocks and you've got sky and you've got wheels. So, if any of those aren't really up there in your favourites, there's not a lot to look at as a rover.
So it's got a few pictures of rocks and wheels. And then it's turned out it got its first colour image. So colour photograph came through, which is just... If you're really, really pessimistic, you can say, well, it's just more colours of Mars. It's sort of, this kind of slightly washed out sepia kind of tone.
Yeah, I mean, if it would be really exciting if we saw this rainbow of colour and the trees over there, and over here is a bright blue swimming pool. No, it's not like that. It's kind of, as you say, sepia-coloured rocks everywhere. Still,
it is very cool. And we also got our first panorama, so we can see kind of where what the horizon looks like to Perseverance, and you can see some very distant mountains and exciting things like that.
It's landed in a crater. Is that right?
That's right, yeah.
Crater or what they think is an old seabed or something. Is it a crater?
Yeah, so we think that there might have been an ocean or a sea in this kind of crater in the past, and that's a big reason why Perseverance is actually there, because it's going to be looking for, I guess, if you look at kind of Perseverance's mission goals, there's two major strands to them. So first of all, there's the kind of the science side, which is Perseverance is a astrobiology rover. I think that's a fair description.
That's exciting just to say.
Yeah, exactly. So Perseverance is looking for past habitability on Mars. So in the deep dark depths of Mars's history, was it a habitable place? Could life have been there? That's an unanswered question that Perseverance is hoping to put some data towards.
Yeah, because so far, like a whole bunch of very tantalizing maybes around water. Maybe there was water. We know that the atmosphere of Mars was very different in the past, right?
Exactly. Yeah. So if Mars used to be a lot different, then was it habitable when it was different? I guess is the question.
And then wasn't there a number of years back, breaking open some of the rocks and seeing, are those kind of the same kind of structures that you would see in a rock left behind by tiny little wiggly microbial things, or not? Are they just geological structures? And I don't know that ever really got 100% resolved, but it was very exciting for a while. It's like, have we just found evidence of bacteria on Mars? Maybe
no
not.
Is definitely the answer there. So
okay, so that was a no, was it?
That was a no. No,
okay.
Actually, I think what you might be thinking of is actually there was a meteorite on Earth that came from Mars.
Oh, that's what it was. Yes.
And we cracked it open, and there were there's a very enduring image of kind of what looks like little cilia, like little bacterium. That's actually a natural formation, and
right.
Even at the time was not really kind of pushed as being, hey, we found ancient bacteria, but it's one of these things that kind of spiraled out of control a little bit in the press.
Yeah, I mean, I definitely remember it doing the rounds, but okay, I will let that one go now. But there's plenty of possibilities.
Exactly. You're definitely on the right track. So what we are looking for, and as well as was Mars habitable in the past, is actually trying to answer the question, if it was, could some of those biosignatures have been preserved in, let's say, rocks? Could you open up a rock and find something which would tell you that there was something biological there in the past? Whether that's probably not going to be kind of like a fossil of a crab or something like that, but it might be something like a gas sample, which means that the atmosphere was in some kind of imbalance caused by some kind of microbial, bacterial life, something like that.
Right. So when you say that this mission has an astrobiology bent to it, I'm assuming that means that a lot of the equipment on board, a lot of the experimental gear on board Perseverance is designed to be able to sort of analyze samples and look for very specific things around, let's do a chemical analysis of this, let's compare it to this, let's have a look at this. Was I reading the other day that they've actually got a bit of Martian meteorite there for comparison? That on board Perseverance?
Possibly, yeah. I mean, there's a few different bits and pieces that Perseverance will be looking at. It's got its own kind of spectrometers. It's got SuperCam, which is an upgraded version of what Curiosity has. You might remember Curiosity's got some like little lasers that it fires at rocks to get some gas off them to measure what the rocks are made of, that sort of thing. But even, I guess, more useful for us in the longer term is that Perseverance is going to be what we say caching samples. So Perseverance itself can't do a lot of really sophisticated lab work. I mean, it's doing the best it can, but there's only so many, instruments you can fit on something that's about the size of a Mini, right?
Yeah, sure.
So what it's one of its main primary goals in terms of the astrobiology side as well is to take some really good samples from different places that it's going to explore over the next few months and kind of squirrel them away, take them, seal them all up, squirrel them away, cache them in a central location with the idea that one day we're going to go back, pick them up and bring them back to Earth and actually have a look at them in our labs.
So it's not just taking a look and making a few tests. It's saying, I'm going to hang on to these. That's a keeper. Right, that one's going straight to the pool room. Well, hang on to that one, and we collectively as a species at some point in the future will come and grab them and take them away. Why would we do that? Is it like if we're going to go all the way to Mars and pick up the samples from the rover, why don't we just go all the way to Mars and pick up our own samples? Like, why does Perseverance need to keep them for us if we're going to go there anyway? I'm a bit confused by that.
I think what the idea behind putting those samples together is that the pickup mission might not be quite so sort of sophisticated. It won't be kind of a rover in itself that's going to go around and sort of pick up like with its little arms and say, "Oh, I'm putting it in my backpack and I'll go over here and pick up." It'll be a much more kind of straightforward craft that will land, grab the things, and then try and take off again, rather than they're having to have all that extra equipment on board.
Right. So my mental image of a bunch of astronauts getting out of the spacecraft going, "Oh, it's been a really long, I just need to stretch, need to have a wee," and then going over to the rover and opening up the hatch and going, "Right, we've got the samples, let's take those back to the spacecraft." That's not what we're talking about. We're talking about a mission which is going to go and collect. And how they do that, I mean, I'd be intrigued to know. What are they going to do? Land on the rover? How is that going to work? I don't know.
Well, I think it's going to store them in a little cache. It's a little bit like a squirrel going and grabbing its kind of nuts and sort of scribbling them away into a little central location, and then we'll come back to that location in the future. And
that makes more sense. See, I'm glad someone's thought this through, because if it was up to me, this would be just a total balls up. We'd have nothing to work on here. Good. Well, that's cool. I like that. The other thing which Perseverance has got on board, which is very, very exciting, and we're gearing up for a bit of a test of sometime soon, I think, is its little buddy. It's got a friend.
It does. So this is kind of the other side of Perseverance mission. So it's got the scientific goals, the astrobiology that it's going to do, and then the other half is actually just how far can we push technology? Like we got to try new stuff. We want to eventually get people to Mars, and there's a long list of baby steps we've got to do before we get there. But let's start carrying on and making all these steps so that we do get there one day.
I don't know. I mean, if you listen to Elon Musk, I mean, he was talking a while ago about, look, I reckon we could get 1 million people to Mars by 2050. And it's like, what are you, like, if you actually do the maths on that, basically means we need to start sending people now. And like, no, this is not going to happen. But hey, that's Elon Musk for you.
Yeah.
Yeah, we got a lot of technology to sort out. So what are they doing?
So as you say, one of the pieces of technology is Ingenuity, and Ingenuity is actually, it's just so cool. I mean, this is basically a helicopter that we're going to fly around from Perseverance and see if we can actually just fly a drone, basically. It's the first question. Can we do it?
Yeah. And this is the first time that we would be trying to fly in the atmosphere of another planet, as opposed to sort of, coming down and trying not to crash on the surface, trying to land in a controlled way. Landing is not the same as flying. Flying is actually under your own power. I'm going to go up and across and down again. And this is a little droney thing that is going to try to do that. When I say little, I think it's actually a bit bigger than I imagined. In my mind's eye, it's like a tiny little one of these little model drone toy things that you can buy for 100 quid or so and zoom around and take pictures. I think this is a bit bigger than that.
Yeah, it's just under 2 kilos in mass. So, well, I guess the larger drones that you see out there today would be sort of similar size, except it's not like a drone where you've got, like, most of the drones I seem to see these days have these kind of 4 helicopter segments, and they use that to sort of steer themselves. This one's just got 2, like more like a traditional helicopter, more like 2 rotor blades, one on top of the other.
Yeah. But I'm just looking at, like, the actual, it's a couple of kilos, so it's very light. But I'm just trying to look it up here, the actual size rotors. Yeah, so each rotor.
Yeah, well, you can see it in scale next to Perseverance.
Yeah, so each rotor is bit over 1 meter.
Right, yeah.
That's not a tiny little hold it in your hand drone. This is quite a big helicopter-y thing, even if it is very light. And I'm guessing that the reason for that is that flying in a very thin atmosphere is actually not very easy.
Yeah, you need stuff to push against, don't you?
Exactly. And so if the atmosphere is very thin, then you need a much bigger blade to be able to push against a much smaller amount of air or atmosphere in order to get you off the ground. So even though it's quite light, it's actually fairly big across. It's not a tiny little thing, but it's very, very cool. So that is kind of at the moment sitting on the underneath of Perseverance, up in its belly. But at some point, it's going to drop it down onto the surface, back away from over the top of it, because its wheels are out on the sides, right? Perseverance's wheels are out on the side, so it'll back away and just leave it there on the dirt and test it out.
Yeah. It looks really funny when you see the animations of this, because it's sort of like it just sort of drops it. It's like it sort of gave birth to this little thing and then backs away slowly. Like, what is that?
Okay, little Ingenuity, now go and do your thing. And so, do we know when that's likely to happen?
Yeah, so we're probably looking again about a couple of months' time for that.
Right, so there's a bit of time to go.
Yeah, so again, it's all part of this very slow and cautious sort of testing to make sure everything works. I think they're going to start potentially driving Perseverance just to start it actually moving, hopefully sometime within the next week or so, and that will only just be a little drive of a few meters, let's say. But then it will start doing the testing. I think it's charging up the batteries of Ingenuity at the moment. Ingenuity is actually powered by solar panels, whereas Perseverance isn't.
But Perseverance has got solar panels on it, but it's not completely powered by them.
It's powered by its own little nuclear core. So it actually makes Perseverance a lot more versatile than many of our previous rovers, which have relied on solar energy. Because when you get dust storms and things like that, then that can be a real problem.
Yeah.
Obviously, with your solar. So Perseverance can go day and night, dust storm or no dust storm.
So it's got a nuclear core, it's a nuclear powered rover, but we've got a solar powered little helicopter-y thing, which is really cool. I'm just looking at the diagram of it here. So it's basically just a little foil covered box with 4 legs coming off it, and these 2 rotors above, and then stuck on top of the rotors is the solar panel and some antennas for communication underneath that. Has the helicopter got, like, it's got to have other stuff in it as well? We're not just sort of looking, can we fly a helicopter on Mars? Tick, yes, or cross, no. It's got to be more to it than that.
Pretty much. It's pretty much just got a camera and that's about it. I mean, I think they wanted to keep this one very simple. This is the first go that we're having at it. But the idea is that in the future, particularly, we'll be able to use this kind of technology to scout. So there's a lot of when you've got a rover, it's not just kind of like, again, it's not driving. It's not, you're not playing on your PlayStation sort of simulator of, Perseverance, and you're driving it along and seeing, where you might want to go. Of course, we've got this time delay. So
yeah, it's a 20 plus minute time delay.
Yeah. So you've got to sort of take a picture and then drive it forward and think, oh, is that rock going to be a problem? Are we going to get over that rock? Okay, take some few more pictures. Let's stop it. It's quite a process.
It's got to be an exercise in the most extreme levels of patience, being the people who are the ones responsible for operating the rover as it is moving around. I mean, as you say, it's fairly autonomous, but at the same time, there's still got to be a very, very strong feedback loop of, all right, so we're just going to move you forward a bit. See how that goes. All right, go and do that. And then I'm going to go make a sandwich. And then we'll come back and see how that went. And say, okay, we're going to try to make it around that rock over there. That's going to take us a couple of days. And it's just, you really have to go through a lot of training to just reach that level of zen, I think, as a NASA mission specialist working on that kind of thing. Because your desire would be just, go, little rover. Come on, let's go as quick as we can. You can't. You just can't do it.
No. So the idea with these drones, of course, is that you can sort of look behind the rock and then sort of see, okay, well, I can map out the immediate area, and that will hopefully help us to be able to sort of move around the surface a little bit more efficiently.
Right. So depending on how successful Ingenuity is, there may be a bit of that. There may be a bit of just fly up ahead and just have a look behind that big boulder and see if there's anything there.
Yeah. It might not be with Ingenuity itself. Ingenuity's just got there's a lot of gearing up for this. It's only going to do 5 90-second flights is what's planned.
Okay. So we're being really ambitious in that, can we do this at all? But we're scaling back the ambition to, if we answer yes, we can do this, that's plenty, That's enough. We don't need to try to solve all the problems with this one. That's great.
Yeah, I mean, just don't expect to be, having this particular little drone flying around the entire surface of Mars, going off and
Right.
finding all the other rovers and things like that. It's not designed to do that. It's just designed to do a few little test flights.
It's not going to be buzzing Curiosity anytime soon.
No. So I think, again, on the pushing technology side, one of the other experiments that I think is worth mentioning, just briefly, is we have also got a experiment on board where Perseverance is going to be trying to produce oxygen from the Martian carbon dioxide in the atmosphere.
Ah, right. And of course, that's pretty important. If down the track, Elon does want to get his 1 million people to the surface of the Mars, then those people are going to need to breathe something. And carbon dioxide's not going to be that. So
Exactly. So again, just a very early test to see, can we do it? Can we do it on Mars? But I thought that was quite a cool one because, again, this is looking ahead of what we can do on Mars in the future.
Yeah, that's very, very cool. Any other experimental bits and pieces that stand out to you?
Well, the last one I think is actually something that we've never done, weirdly, something we've never done before, is put microphones on our rovers.
Oh, have we not done that before? Because I know that there's been a lot on the social medias of listening to the surface of Mars. And actually, as I mentioned earlier, there was some fake news going around of here's a video of the surface of Mars and listen to the sound of the wind. It's like, no, that's just the wind here on Earth. You're making this up. But they really do have microphones, and we really haven't done that before.
I don't think we've put them on the rovers before. So Perseverance has 2 microphones, and we've got the first audio just come through the other day, which is, first of all, I guess that they've got to sort of filter out all of the sounds that Perseverance itself makes, because, it's got little instruments on board, much like I'm sitting here in a data room with all sorts of computers and things whirring away. Perseverance whirs away.
Weird. Mars sounds like a piece of machinery. I can't figure it out. Yeah.
So they had to filter all that out. But when you do that, I was listening to it, and I was actually thinking, okay, it just sounds like wind. It's quite windy outside here today. Sounds a bit like that. I don't know why I expected anything else. I don't know.
What else could it be, right? It's like, dump, dump, is this thing on? Like, you're not going to have like ukulele sounds or something. It's not whale song. There's not going to be any of that. It's just going to be, oh yeah, that sounds like, fluid moving past a microphone. That's basically what it is. And yet, it's still pretty awesome that what we're listening to. I mean, it's like the first time that you get that low resolution, or indeed, even more impressive, the high resolution images coming back from the surface of Mars. Just take a moment to think about that for a second. That's actually another planet.
Yeah.
Some of the really high resolution pictures that Curiosity sent back, particularly its selfie pictures where it sort of stuck out its arm with the camera on it and looked back on itself. Some of those are just breathtaking when you think that's not CGI. Like, no one's made that up. That's the real McCoy. That's pretty cool. I like that. Well, Emily, that brings us to the end of a very Mars-filled, very sort of red planet-focused edition of the Syzygy podcast. We talked about Mars before, but I don't think ever quite to this level, because there's never been this much going on with Mars on the podcast before. It's very exciting.
And we're going to have to come back to it over the next few months, because as we say, we've got Tianwen-1 going down, we've got, Perseverance is going to let Ingenuity fly, so there's going to be lots to talk about over the next wee while.
Yeah. So, I mean, apologies to anyone listening if you're not really into Mars in a big way. I mean, first of all, what the hell's wrong with you? And secondly, sorry, but there is going to be a lot. At the very least, there's going to be a lot of data dumps eventually from each of these missions saying, guess what? We found this. What do you make of that? So there's going to be a lot to talk about as they test out their equipment, they start exploring around, and they start taking samples and figuring stuff out. So, yeah, I'm guessing 2021, 2022, it's going to be a lot of Mars-focused stuff on the podcast. Something to look forward to. Listen, if you are a space geologist or anyone who's got any kind of input for the stuff that Emily and I might have got wrong during this episode, because I think there were a few moments in the episode, Emily, where you and I said things which was, I'm not quite sure about that. If you are sure out there in Listener Land and you wanted to get in touch with us to say, here's the thing that you don't know, then there's a bunch of different ways that you could do that. Emily, we talked about Twitter. If you're following at NASA Persevere, you should also be following us on Twitter. How would they do that?
Well, it's just as easy as sticking in at SyzygyPod, SYZYGYPOD.
That's right, because it turns out that SyzygyPod is where we're at on a lot of things on the interwebs these days. We're on Twitter. Where else are we?
We're on the Instagrams, gramming up with good old Perseverance. We're on Facebook under the same handle as well.
That's right, or just search for Syzygy Podcast. You will find us. The other thing you can do is go to our website, syzygy.fm, where you can find this and all past episodes, all of the show notes, all of the pretty piggies, everything, as well as two things. One, a contact form where you can get in touch with us and say hi. And two, the Great Wall of Thanks, where all of our supporters, particularly our wonderful patrons through patreon.com, who pitch in financially to help support the show. So all of their names are up there in great glory. Thank you to everyone who's supported us. And if you would like to support us, just go to patreon.com/syzygypod. There it is again, where you can sign up to become a financial supporter of the show, keep the electrons flowing, and allow us to go out and do things like festivals when the world does eventually open up. No more needs to be said about that. The other thing you can do to support the show is to tell people about us. Go and find your nearest interested space nut and say, there's a thing you should be listening to. They talk about Mars, they talk about black holes, they talk about everything in between. Go and listen to them and point them in our direction. Leave us a review, leave us some stars on your podcast listener of choice. It helps us to rise up through the noise and attract more listeners, which ultimately is what this is all about. Anyway, that's enough from us in this particular edition. We'll be back in, a week or two. Emily, how long are you going to be there in your observatory trying to observe through, we hope, a parting in the clouds?
Yes, well, I'm going to be here for another 10 nights or so, so I think we should definitely squeeze in a bit more about how to do this kind of professional observing in the next week or so.
I think that would be great, because I'd love to know what it is that you're actually trying to do should the clouds actually eventually part and give you a chance to do it. So how about we have a chat in a week or so, and that means that listeners, you'll be hearing from us in about a similar kind of time frame. So until then, Emily,
see you later.
Bye, everybody. I've just been having a look through the Perseverance Twitter feed.
Gorgeous
Stuff on here. Have you seen the little family picture that's actually on board Perseverance?
No.
It looks like one of those, on the on the back window of cars. You've got the family cartoon portrait with the mum and the dad and the kid and the dog. It's one of those. Hang on, I'll send you a link. And did you see the code that was on the parachute?
No.
Oh, yeah. Fabulous stuff. Got so much to talk about.
Oh, I know. It's just going to go on. That's good. I just love the quirkiness and how somehow, I don't know if this is because they assign different people to each of the different kind of rovers and so on, Twitters, but they do end up sort of having their own little personality, which is really cute.
Yeah. Yeah.
Oh, look at the family.
Isn't that lovely?
It's so cute.
And that's actually on the deck of Perseverance, driving around up there, which is
nice.
really quite sweet.